Starting. Start broadcasting. Hello. I have no idea. There was something to do with the mute on this as well. Mute microphone.
Yeah.
Hey. Hello. Well, viewing. Group chat. Hi, you 11. 1 viewer. 5 viewers. Right, guys, can you hear me? That's the big question. Give me a thumbs up or a thumbs down. Wow, this has been, I'm sorry it's taken me so long, guys, to become live. I still kind of haven't figured out what I did there to make it work, but I seem to have it working now. So I've now got 6 viewers. We're doing well. So what I'll do is I'm going to give like 1 more minute for people to join, and then I'm just going to start. Does anybody want to lob me a... I have no idea who's viewing. I wonder whether or not anyone wants to send me a message on the group chat. Let's see if you guys can get my messages. I've put hello. Who's going to appear? I'm sorry I'm late, folks. I'm 13 minutes late. I do apologize. We had a minor fit with not being able to get it going. Let's see if Miss Childs can get a message up onto the chat. No? I've now got 10 viewers. Cool. Oh, okay. Comments are not supported. Okay, guys, I've got 10 viewers. Let's see if I can screen share. Try doing your entire screen. Let's try that and see what it does. Oh, wow. I have no idea what's... Oh, I think you are screen sharing. Present to everyone. Let's see what that does. Wow, I have got 1 million screens up, which is awfully strange. Let's see if we do this and then do that. Let's see if I click on full screen on that. I'm hoping that you guys are going to see what I see. Yeah, there we go. Right, guys, I think everyone can see, hopefully see, page 1 of your exam paper. So what I'm going to do in this chat is I'll walk through kind of common answers that people have put that are wrong for the question. I'm also going to give you a shout out in terms of the percentages that each question have scored. So question 1 has been done universally well. We've got a 90% score rate on question number 1. Now, I'll try and do it a little bit slowly if I can. It's just to walk you through the numbers, and everyone's going to think this is an easy one, so that should be good. So it asks you to fill in the table. Now, you can see what that I've done the paper, and I've put in model answers that you guys can copy across onto yours. So they can be, you can put them in as green onto your papers the way that you usually do the notes that you write onto your exam papers. So question number 1 asks you for the atomic number of the atom. So that's flagged by the key on the right-hand side here being protons, and you can count them in the diagram. I think the people who struggled with this question were simply not looking at the diagram. Number of shells, of course, is the number of circles surrounding the nucleus. Followed by the mass number, of course, is 7, looking at the nucleus and seeing the total number of protons and neutrons. Number of protons. Now, this is the one that's foxed people in the 10% bracket. the number of protons in an isotope of this element. Now, people haven't understood that the isotopes have the same number of protons and electrons and only a difference in neutron number. So that number would always be 3 if you've got atoms of the same element, and even though they're isotopes, you'll still have 3 protons. The group that it exists in, of course, is all based upon the outer shell electron number, and you can see I'm just circling that one, showing that the outer one has just got 1 in it. So that's going to be group 1. Going on to question 2, the pass rate for this one was 70%, so it dropped a bit, partly because you'll see that I've circled name in the question. Lots of people wrote in formulas. Now, we've been a little bit generous on this, and we've given marks for people writing in the formula of iron 3 oxide. We also allowed it for iron 2 oxide as well, because you'll be actually forming a small amount of each one, but the one that they want is iron 3 oxide being the most common. So just watch out on those questions when it says name. Lots of people are writing Fe2O3 in the answer, and you would have lost it because the question specifically says name. The next one, of course, it says name the 2 substances that iron reacts with when it rusts. This is just a knowledge-based question. Again, people writing in H2O instead of the word water, watch out for the name. Water and oxygen, easy additions. It then asked for the type of reaction that rusting was. And it runs through the options of combustion, decomposition, displacement, but of course the one that they're after is oxidation, because we're adding oxygen to the iron in that process. So the gain of oxygen being oxidation. Another one being a knowledge-based question, identify the metal we use in galvanizing. Just got to know this, folks. So that's zinc. So we coat metals in zinc. Then it asked a rather nice question. Majority of students got this wrong, realizing what objects we galvanize. Lots of people were putting bicycle chains, car engines. But for the bicycle chain, you can't galvanize because it's moving on a frequent basis and being rubbed against other metals. So you'd scratch off the surface. So oil would be for a bike chain. The bucket is what we galvanize. Buckets, of course, we put water into. So that's the main reason why we galvanize them. You can't use oil because it'll wash off. You could use paint, but it'll chip, being the fact that it gets used on a regular basis. So galvanizing is a slightly more robust coating. Car engines, well, they're made of straight flat steel, so they tend to rust. Drinks cans, of course, are aluminium. If they use steel, then of course they coat them in plastic, but they'll be using stainless. So what we galvanize, and that's covering in zinc, is a bucket. Anything that you're going to be putting water into, we generally galvanize. It then asked for 2 other methods to prevent rusting. Lots of students here wrote down to cover with a sacrificial metal. That's galvanizing. Now this question was tricky because the problem was it gave galvanizing, and galvanizing is a type of protective layer, not strictly speaking a type of sacrificial metal. So it was rather unfortunate that the mark scheme said do not allow this. They wanted you to give oil or paint or coat with a plastic. Another thing, I think what they were going for there is looking at the options above and how it would be paint is used for drink cans, hence the Coca-Cola sign paint on the outside and the bicycle chain with oil. They were looking for an application to the question above for those 2. Right, so on to the next page. The question 3 is at the bottom, saying the states of matter, diagram shown. So, okay, going on to the next one. It shows you the good old year 7 state diagrams of solid, liquids, and gases. This was universally done well for the first part, so for question 3, this was at 95%. This was the best answered question on the paper. So the change in X, of course, from liquid to gas is boiling, going from gas to liquid, condensing, and of course, liquid to solid, freezing. Nice, straightforward question. Do be aware that those questions, when they do arise, quite often sublimation will make an appearance with that one, going from solid straight to gas. But in this case, it was very straightforward, going for a low ability question, and everyone seems to have done pretty well. Which statement best describes the movement of the particles? So this one's quite an interesting question, because what they were wanting you to do is process of elimination. Because I think a lot of people would say spaced out, fast moving. The option C, of course, particles move freely is what they wanted, but you had to do it via a process of elimination of particles vibrate around fixed position, not a gas, solid. Particles slide past each other, liquid. Particles do not move at all. Well, that's never true. Particles are always vibrating. On to the next one, which is we're doing calorimetry now, making an appearance. Name of the apparatus. Everyone seems to be doing pretty well on that one, giving our thermometer. The next question was interesting, because the mark scheme gave a variety of options, but it said explain why water is not a suitable liquid to use for the experiment. And it said solid Q melts. The hint was in the melting point. So solid Q melts at 140. We know that water, so the answer was water boils at 100. So you can't melt Q. You know that water can't go above 100 degrees Celsius at atmospheric pressure. So that was the trick to that one, knowing your boiling points. Suggests why the liquid in the beaker needs to be stirred. Everyone seemed to get this one, which I was really pleased with. So we need to make sure that the temperature is even throughout the beaker or water, so that when you're heating it, it's not hot at the bottom, so it would give you an incorrect melting point. But otherwise, that question was universally done well. As I said, 95%, which is good. Going on to question 4. So question 4 was a little bit tricky. Pass rate was still pretty good at 70%. But the key one really for me to go through is question B. Most people got the order wrong in some respect, but it's nice to go through the different separation techniques. So red ink from a mixture of colored inks. The trick to that one is mixture of colored inks. You've got lots of them. Well, you're never going to be able to separate them through distillation, because the colors wouldn't come out with the solvent that you're using. So to separate colors, multiple colors, you're going to want to using chromatography, leaving them behind on the paper. The next question was really clever, because it gave you ethanol mixed with a mixture of ethanol and water. So they've given you 2 liquids. Now, lots of people would argue with this question and say that you could potentially use simple distillation. You can't. The reason being is the boiling point of ethanol is 78 degrees Celsius, whereas water is 100, and they're rather close. So what that means is if you used simple distillation, then you're never going to produce a pure liquid. So what you need to do is add a fractionating tower on top, which will increase your ability to separate these two, hence producing a purer sample of ethanol. So fractional distillation is your choice. Sand from a mixture of sand and water. I think everyone got that one. Filtration, which was good. Water from copper sulfate solution. So this one's, you want the water. So we're doing simple distillation to leave the salt behind in your round bottom flask, and you're going to distill off your liquid. Because it's a solute dissolved in a solvent, you can do simple distillation because there's only one liquid, which means you're going to have no issues with liquids having similar boiling points. Which one of P, Q, R, and S contains an undissolved solid? So we're the only one of that's a solid there. You should have run through the list. I think most people got it. The only solid that people should recognize there is sand. Sand is not soluble. It's not soluble in any solvent. Giant covalent structure. It's always going to be there. I think majority of people got that. Right, the next one. This one's an important one to run through. Pure dry crystals of magnesium nitrate can be obtained from a solution by crystallization. Run through the steps. Now, the key bit to this was they gave you E. They told you that the second step was to dip a glass rod into the solution to see if the crystals are forming. Well, if that's the case, heating the solution to evaporate some of the water must have come first, because when you're removing some of the water, you're increasing concentration. Eventually, you'll reach saturation, and as soon as you touch the surface with the cold glass rod, it's going to precipitate out. So B was first. Then, of course, was A, allow the solution to cool to room temperature. This is going to make all of your crystals reappear. Then followed by pouring it through filter paper to remove your crystals, and then, of course, putting them in to dry. Now, just to offer you a suggestion for these particular questions, everybody has struggled with these throughout the entire paper. There are 2 other salt questions that are going to come later on. And the trick to remember is D is always going to be last. Drying crystals out is, so you could have done this via a process of elimination of putting D in the last box and slowly putting the rest in piece by piece. So you're always going to be drying. So what's going to be coming before drying? Well, you've got to get onto filter paper. So that would have been C coming before D. So in reality, that question would have been more easily accessed if you ran it in reverse. So that's something to bear in mind for the next time. If you ever get these, here are the steps, put them in order, try to spot the last one. It's always a nice thing to aim for. Question number 5. Question number 5 is the first one that only 50% of students managed to do well on this question. The scores are all low, so it needs to run through. So question number 5, I think everyone was okay with exothermic. Heat energy, now you'll notice that even I had made a bit of a blunder on that, and I almost wrote heat is, and I immediately recognized my mistake and thought, wow, it's easy to just write heat is released. You can't say the word heat without the word energy following it. So heat energy is given off to the surroundings. Next one, of course, right, the atom pictures. These were a bit of a disaster. I think students were not realizing the importance of the periodic table for this question, and realizing that oxygen you find on the table. You find its group number, and of course it's group number 6, so 6 electrons in the outer shell, and so it's going to be D. There were no other options there. They all have 2 shells, but only D has got its 6. Okay, so then moving on to the next one. The next one said, put a cross in the diagram. This is at the bottom of that page on the right-hand side. Put a cross in the box that indicates the electronic configuration of an oxide ion. So then it gave you your options. There was only one choice here. Now, unfortunately, the question tricked up a couple of people because they broke a rule, which is if you're going to have an ion, you should have dots and crosses. Well, to make the question a little bit more tricky, they've put them all on as crosses. So the bit you needed to spot was the charge. So in A, you can see that it's a 2- charge. And oxygen being in group 6 is going to gain 2 electrons, each electron being 1-. Therefore, you're going to end up with your 2- charge. And the only one there with 2- is A. Okay, D, right. Structure and bonding. This has been a disaster across the year group. Now, I've done this in a particular fashion. Students that have been coming along to my revision sessions on Friday lunchtime might recognize this. So I use an acronym. You can see it running down the left-hand side I use Susan Boyle sings Nellie the Elephant, and you can see the starting letters that allow you to build an answer which will hit all 4 marks for structure and bonding. This question for me was a nightmare because what happened was students were throwing in every bonding type. They were saying words with ionic, then throwing in covalent words, and you need to realize that each one is a story. It's got to be learned. So we've got magnesium oxide, metal, non-metal. So that's going to be ionic. So the structure, that's what the S stands for. Magnesium oxide has a giant ionic lattice structure. You'll see how I've done this paper as if I was sitting it for a real exam, creating full sentences. The next one was B for bonds. The structure is held together by the electrostatic attraction of oppositely charged ions. There are the bonds. Now, you were allowed to say, and you are at GCSE allowed to say, the structure is held together by ionic bonds. That is allowed. Prefer you not to. It's good training for A-level. The next thing is, the next S is strength, saying that the electrostatic attraction is very strong. Next one, of course, the N is number. There are millions of ionic bonds to break and lots of energy, and the last one of energy, lots of energy needed to break them. Yeah, so high melting point. This pattern is one that we need to make sure we reinforce by looking at these questions in our revision sessions on Friday lunchtime. And I'll be doing that over the next week or so. Right, next one, formulas which people really struggled with. Magnesium oxide is also used as an antacid, neutralized with hydrochloric acid in the stomach. Name the salts. So the magnesium oxide is going to become magnesium chloride. Hence, hydrochloric acid always produces a chloride salt. The formula, of course, the majority of students writing MgCl, not bothering to take their time to consider their formula. Just remember, magnesium is in group 2, so is a +2 ion. The chlorine is in group 7, and it's going to become a 1- chloride ion. So you're going to have to then have 2 chloride 1- to cancel out every one of the magnesiums, hence MgCl2. Okay, going on to question 6, another poorly asked, in fact, second worst answered question on the paper at 35% across the year group. And I think the majority of students would agree that this was a tricky question. It wasn't easy. So we've got bromine and chlorine and iodine are in group 7. Please tick the boxes that have 3 correct statements. So this was a case of going through them. This wasn't done too badly. Majority of students either got 3 or got 2. The elements can be obtained by electrolyzing molten metal halides. This is true. If you do molten, you'll always make the halides or the halogens in their diatomic states. The elements with paler colors are lower down. That's not true. Fluorine being, of course, pale green, pale yellow, then chlorine being green, bromine being brown, iodine being black. So it's getting darker as we go down the group, so that one's wrong. Boiling point decreases, not true. Fluorine a gas, chlorine a gas, bromine is then, of course, a liquid. Bigger molecules, stronger, weak intermolecular forces, dropping into covalent bonding. And then of course, iodine being a solid. I always say to students to remember that answer based upon their knowledge of group 7 states. Everyone knows that chlorine's a gas, used in World War II. A great piece of knowledge to be able to use from history. And of course, iodine is a gray solid. Bromine being the only one of 2 liquids on the periodic table. Nice way of knowing it. The elements form covalent compounds with other non-metals. That's true. Non-metal will form covalent bonds. So they're going to form covalent compounds. So that one's true. Their molecules contain 2 atoms. Absolutely. They're all diatomics. That one's correct. All are gases at room temperature. Not correct. Bromine and iodine being liquid and solid, respectively. Next equation. Equations. These need work. Everybody in year 11 needs to be working on their equations. So it asked you to write a chemical equation. Now, a common question that all students ask me is, if the question in my exam asks me for a chemical equation, can I give it in words? And the answer is no, you can't. If they're asking you for a chemical equation, they're looking for a symbol equation. The only time that you'd write a word is if they say, write a word equation. So this is asking for symbols. So potassium, of course, is a metal going in on its own, because only 7 elements are diatomic, plus iodine, which is I2, and you had to form Ki. Now, the tricky bit, of course, was a lot of people put Ki2. And common mistake, very common. People, again, not considering their formulae. So potassium being 1 plus, iodine being 1 minus, and you need to balance. Tricky question, that. Very few people getting it right. As low as 10%, I seem to recall. The next one is states of matter. Tricky one. So it's then said hydrogen chloride. What's its state? Most people put a liquid. I get it. That's because you see it in bottles every day. I totally understand. Unfortunately, hydrochloric acid is a gas. People often then ask me, of course, about nitric and sulfuric. Both of those are actually liquids at room temperature, but their molecules are larger, so stronger, weaker intermolecular forces. Just now, this is a key one for you. It's asked you for the state of hydrochloric acid. Here's a rule, year 11, which is all acids are aqueous. All of them. No choice about it. You can't be an acid without being aqueous. So it's a nice rule. As I said, the majority of students would put liquid in for the HCl one, so I wasn't too upset by that question. This question, one of the hardest questions on the whole paper. Very low scoring. People were scoring 1. I think only 2 people scored 3. In fact, I think only maybe even 1. A few 2s, but the majority were either 1s or 0s. Probably one of the hardest questions on the paper. Hydrogen chloride is dissolved in methyl benzene. Students are freaked out when they see compounds they don't recognize, and I understand that, because they'll go, "Oh, I don't know what methyl benzene is," and unfortunately, dealing with that is difficult. You have to remember that the information is going to be in the question. You pretty much, if you ever get scared by a compound, cover it up. Cover it up with your thumb, it'll make it feel better. When a piece of magnesium ribbon is then added to the solution, there is no reaction. When water is added, the mixture is shaken. A reaction occurs. Explain the observation. The key thing here was looking at the mark scheme. Most students didn't realize that there are 3 marks here and were saying a whole load of waffle, spending a good, reasonable amount of time writing in things and scoring nothing. There are clear 3 points here. The hydrochloric acid ionizes. We know that acids, the reason why they're in acids in water is because they break apart in contact with water to form H pluses, 1 mark. The H plus ions react with the magnesium to form hydrogen gas. Now the last point, no, I don't think anybody got, and it's partly the question itself was written trickily because it said trickily, it's not even a good word. It says a reaction occurs, explain the observation. It hasn't told you the observation. They're wanting you to say what it was. Metal plus acid, salt and hydrogen. You always see fizzing. A reminder here for all of year 11, please remember, a lot of students will say, you will see a gas. That is not allowed. You can't see gases. Gases are colorless and invisible. What you will see is bubbles or fizzing. Something to bear in mind if they're ever asking you for observations. If you ever write down, you will see a gas, you're wrong. You're looking for bubbles and fizzing. Okay, on to the next one. Next one, nightmare question. This one, again, really tricky. Explain which test gives results that cannot be used to compare reactivities. Lots of students got test number 2, which was good, scored 1 mark. Test 2 can't be used because they've got chlorine with sodium chloride. The trick for the 2nd mark was really tricky. Lots of students were writing down saying the chlorine can't displace the chloride. You can't say that because actually it can, which is a nightmare. Because if you actually have chlorine in solution, it's going to be producing chlorine ions and they'll be swapping willy-nilly. The problem is you don't see it because the chlorine doesn't react with the chloride ion. And that was tricky, and so what you need to recognize here is just remembering that when they're doing this group 7 displacement reactions, the words are not, it's displacing, the words are the bromine is reacting with the iodide. That's actually what's happening. The iodide is giving its electron, it's reducing the bromine to bromide, and the iodide is being oxidized and losing electrons. So the sodiums aren't doing anything at all. So it was a tricky question, that one, and I think lots of people would be frustrated with the answer because the only thing it said on the mark scheme was, do not accept that chlorine doesn't displace chloride, and it was a nightmare. Lots of people wrote that. Which observation shows the reaction in test 1? Right, the test 1, it said displacement reaction occurred, didn't tell you what's been happening. I always say a good rule for reactions is if you're adding things together and you're not sure what you're making, swap the non-metal. So in this case, you're going to form iodide. Sorry, the iodide is going to become iodine, and iodine is dark brown in solution, so it becomes darker. Effervescence. Nope, you're not going to see any gas being made. Purple fumes. Nope, purple fumes is the idea of iodine coming out as a gas. It's not going to, it's in water. White precipitate formed. Nope. That was, again, a tricky question, knowing your observations from group 7 there. They like those, they're doing them a lot, so bear those in mind. It's something then if people have questions, can ask me on Friday lunchtimes. Right, this question was an epic fail. I think 1 or 2 students, maybe even only 1 got this right. So this is the idea of combining half equations. Now, I'm the first person to admit that I don't think I've done that enough in my classes. And of course, it will have been taught to you last year, year 11, of course, I didn't teach you. And so it is a case of, if you ever have equations, and the top one, of course, the chlorine is gaining the electrons. So that's going through reduction. On the bottom, the acetaldehyde is becoming astatine and going through oxidation, losing electrons, oil. And those electrons, if you put equations together, if you've got 2 of the same thing on opposite sides, they cancel. You can see how I've done that. I've shown that the 2 electrons on this equation are cancelling the 2 electrons on this equation. So you can then put them together and you can see the overall answer. That question had a lot of people in a bit of a panic just when they saw ionic equation. You guys are used to practicing the half equations. They gave you the half equations and asked you to put them together. I think that's something that not many people had seen. So tricky question, that one. That, by the way, that would have been a grade A star question. A very, very low percentage scoring. Explain with reference to the appropriate species and to electrons why the reaction is described as a redox. Right, 2 marks. There are 2 bullet points here. You needed to describe both reactions. So chlorine is gaining electrons. So going through reduction, tick 1 mark. You're explaining oil rig. That's what they wanted you to do in this particular situation. The acid tide, now common mistakes here is students were calling chlorine chloride and acetide acetine. And you know what? That question is designed to freak students out because you never use astatine. Astatine is a radioactive element. So they've tossed it in there because students are going to go, oh, I've been told that I'm not to use that one, that I just ignore it from group 7. Totally get it. The reaction could be done, but it's ridiculous. So it was there to test your understanding. That understanding question was tricky. You almost had to see through the smoke of the question. Okay, next one, calculations. So this is looking at question number 7. Question number 7, again, 35% scoring, not great. Calculations, and year 11, this is usually what you're strong on. So this was students not taking the time to show they're working and making simple errors by not using the correct equations. You can see how I've done each one. Calculate the amount in moles of magnesium used. So it's then, I've run through my equation, I run over onto the other side to see 0.096 grams of magnesium. Right, so I'm recognizing mass there. So I'm using moles equals mass over MR. Now, I never say that in lesson. I like to say grams over rams because you're always going to see grams in the question. So it's just a stupid method of remembering it, really. But you can then see how I've extracted the data. So I've then put moles. I've then done therefore. Moles is grams of magnesium, put in the number, and then followed by the AR from the periodic table. That's part of the test. That's the first mark in this question, is seeing whether or not you could extract the number 24 and use it in the correct equation. Hence, you can then see my moles being spat out, 0.004. Can I just say, a mistake that was appearing regularly here was students missing zeros. Very odd. You had the correct number, but were then writing in 0.04 and just excluding the second zero. I think this is a great example of what I like to call exam madness. You're feeling a bit under pressure. You had a little bit of doubt in your mind, and when you start copying down numbers, you're not looking at your calculator. It might also be your calculator being in standard form. You're allowed to put that number in standard form if you like. So that would have been 4 times 10 to the minus 3. That's totally acceptable. Some students don't like doing it. I actually don't either. There's a little button on the calculator, which is the ENG button, E-N-G, which will allow you to move between standard form and normal numbers. So if you do Shift-N, it'll change it into a normal number for you. The next one, now you can see the process that the exam board are using here. They've gone from moles in a mass, so moles is mass over MR, grams over rams, and then they've switched into moles in solution. So number of moles is concentration times by volume over 1,000. Now the 1,000 is the mark. You had to realize that you're in centimeters cubed and therefore do a conversion. I roll it into my equation when I do it. I just run through my equation and then again extracting the numbers and then copying over the answer. The next one, this was horrid. Everyone will be looking at this question and thinking, I hated this one. And it was vile. 2 marks. And can I also say that we've actually been a little bit generous on that question because the mark scheme was horrendous. It almost became it was either 2 marks or 0 marks. Because lots of people got that the HCl was in excess, but they couldn't explain it. Now, what was a nightmare was you can't actually get the mark for saying HCl's in excess if you couldn't explain it, which meant it's either 0 marks or 2. Now, I've shown you how I've done this. The first thing I did was wrote down the ratio between the two, and that's from over on the other page, magnesium with 2 HCl, so there's the ratio. I then wrote down the moles of magnesium, which I gained from the part up here. And then I therefore said, I would need 0.008 moles of HCl to react with it. Well, that means that the 0.01, which I calculated, is larger than the 0.08, hence I've got more acid than I need. That's a really hard bit of chemistry. It's interesting that they're asking it, and it's something that, again, needs to be highlighted and practiced. I'll bring some of those questions with me in our next revision session. Next, right, this was the question number 8. Question number 8 was really, again, 50% scoring on this, average scoring. That's poor. People not recognizing the data perhaps being on this side. So it's given you a data table, and yes, there's a bit of flicking going to be going on here. So it then said, what bit of information tells you that they've got similar properties? And the answer was the electron configuration. Lots of students wrote down they all have 1 electron in their outer shell. It was accepted. They did allow it. And you got that, of course, from the electron configuration part. And that question said which part of it, which information shows. You almost had to take the title from the table. The information is the title of each column. That's tricky, that. As I said, it was allowed to say 1 electron in outer shell, but they wanted electron configuration. Reason, all the electrons have 1 electron in their outer shell, and the electrons in the outer shell decide reactivity, their chemical properties. I'm actually realizing that the answer that I've written in there is a model answer. I should have expanded a bit more. All electrons have 1 electron in the outer shell, and the outer shell electrons what decide the reactivity. So I'd like to add a bit more to that next time, perhaps. I was going to do that one again. The elements in group 1 show a clear trend in some of the physical properties. Identify the physical property. Now, that one, I don't understand why students got this wrong. Lots of people were quoting density. Now, that's madness, because the lithium's density was 0.53, so sodium is denser at 0.97, but the potassium is less. There's no trend here. It's going up and then down again. That's not a trend. Trend means pattern, whereas the melting point, nice steady decrease. So there was the physical property that had its pattern. I think there maybe it was the idea of it was the idea that you guys thought there was a trend perhaps, when in fact there wasn't, perhaps not reading the numbers, or perhaps not understanding what the density numbers meant. So maybe that's something to look over. Next, describe the test to show for hydrogen. Right, this one was quite an interesting question, because you had to really describe it really quite well. It wanted you to say, collect the gas in a test tube, light the gas with a lit splint, and you will hear a squeaky pop. Now, what's interesting is there's 3 clear, distinct points there, but it was only worth 1 mark, which means essentially you had to give all 3 bullet points to score it. Something to bear in mind, that gas tests, you've got to give the whole lot. You can't just kind of say, oh, the test for chlorine is damp blue litmus. You have to say damp blue litmus, it'll then turn red and then go bleached, you know, and collect it in a tube and put the damp litmus in it. You've got to kind of describe it in its entirety. So gas tests are something that's definitely worthwhile putting on the learn list. Next, state symbols. So, okay, yeah, this was a good question. So lithium, solid, all metals are solids except for mercury. So lithium being a solid, you'll notice I put the little brackets inside by accident. Oops. 2H2O, of course, being a liquid. Lithium hydroxide is going to be aqueous. All salts, all hydroxides, except for transition metal ones, are going to be aqueous. And that one's one that you've just got to recognize. They all dissolve to form aqueous alkali solutions, and the hydrogen, of course, is gas. The majority of people got that pretty well. I think you will recognize that they wanted all 4 states to be said. It's a nice equation. It's got them all. Really like that one. State and explain the effect of the solution had on red litmus. Right, recognizing your hydroxides. This is from acids base theory that you've done this year with Miss Childs, Miss Alden, herself, recognizing that all hydroxides are alkalis. And so it's going to turn it blue. And then the second mark, again, guys, watch out for the marks on the sides. It's telling you how many bullet points you need. This is 2. It turns it blue, 1 mark, due to the OH minus ions being alkali. They need you, that's 2 clear marks. When you see the scores on the side, make sure, do bullet points. Bullet points are allowed in the exam. They'll just ignore them. As long as it's good quality sentences, they don't care. In fact, they'll appreciate it. Next, similarities. This was a disaster. Students saying all kinds of crazy answers in there. I think at this point, I don't know whether or not exam madness had set in, but students were all kinds of bonkers answers. But I've given the 2, the main ones. Both fizz produce bubbles. Both metals vanish. There were others as well that they would allow, that both metals float. You weren't allowed to say between the state 2 similarities and 2 differences between the reactions. Now the funny thing is that question it hasn't said the word observations. I've given distinct observations there. I seem to remember on the mark scheme that they had other ones include form alkali solutions, both of them. But these were the 2 that they were looking for. Differences. This was a clear thing about choose somebody. Yeah, and talk about one of them. Potassium's reaction is more violent. Potassium reaction catches fire. The bubbles were produced at a faster rate. There were more bubbles being produced. It was moving around on the water more quickly. Lots of answers that were there, and scoring was low. On that there is question, that's question 8, scoring a 50% on that one. Again, very low. This equation, right now, the trick to this one is that they've given you the formula of lithium oxide. They've given you Li2O. And so what that meant is the test really was balancing and remembering oxygen going in diatomically. So you had to lob in those guys and then balance it. Lots of students either A, forgot to balance entirely, put oxygen in as just O, please don't do it. And then, of course, just flat out forgetting to balance, I think, was most common. Lots of people ignored the question as well. Instead of, it actually told you in the question Li2O, and lots of people just put LiO. Read the question, read it carefully. If they're giving you data, use it. Then there's a lovely balance equation. I think everyone in this was like, thank you, an easy question. And you just ran in your numbers. You don't need the ones. I've put them in to make the question very clear. But you could have just put a 2 there and left that one, the oxygen and the sodium oxide blank, and that's totally acceptable. You don't need the 1, but I did it for clarity. Right, we're on to the next salt question. Right, I have attempted in this question, when I've created my model answer, I'm trying to show you a process that you can learn that will make this a little bit easier for you to raise your score points. Right, question 9, this one is the worst answered question on the paper. 20% is the average score mark. That's 1 out of 5 was the average. So loads of people scored nothing. So I've tried to give you a process here. Now you'll note I've put a little circle around lead bromide and put note. This is like a nota bene that I quite often use in lessons, saying an important notice. A lot of lead compounds are not soluble. That's a really lovely thing to know, because it seems to appear a lot. They like asking this idea of insoluble salt, and lead compounds are often insoluble. So that's something to bear in mind, that, and to learn. All nitrates are soluble, by the way. So sodium nitrate, hence the aqueous mark. So okay, it says describe how you could use solutions of this and this to obtain a pure dry sample. Right. So just to give you a little bit of a walkthrough on the question, it was how you use solutions. Lots of people just flat out ignored that bit. They were not realizing that's actually one of the marks. Then there's pure. There's an idea here of purity. And to get purity, it's separation. It's washing, it's cleaning, it's removing. People have missed that. Then dry, that's part of the question. How would you dry it? And I think lots of people haven't realized that. So mix solutions of lead nitrate and sodium bromide together. That was just not said. That's the easiest one, and I think students missed that because it's so basic. It's so, of course we're going to do that. It's told me that in the question, but it actually hasn't. And they were looking at it as a mark. Mix and stir. So the idea that you're going to form a precipitate and then it's going to sink to the bottom, and then if you don't stir these together, and it now wanted to do one of those 5 marks. So you get the 3 from solutions, purify, and drying. There's 3. Well, another one of them was to name pieces of equipment. And you had to name a minimum of 2. Mix or stir in a conical flask. Now, just to say is, you never mix or stir anything in a beaker. You're going to end up making a mess. So that's what the conical flask was designed for. The sloped sides prevent splashing. So mix or stir in a conical flask. Filter, and you'll notice I've put in my second piece of my second and third piece of equipment, my funnel and my filter paper. So filter, this is going to remove the solid lead bromide. Now, when I remove the solid, it's still going to be coated with liquid which contains sodium nitrate, so it's not pure. Now, because it's a solid and insoluble, I can wash it with water. You had to wash with distilled water. Can't wash with tap water. It's full of impurities anyway. So wash the solid, wash the precipitate with distilled water. Place in a drying oven to dry. Now, that last mark, they allowed you to say any sensible answer. So it was hilarious. You could have put in an airing cupboard. I thought that was brilliant. I'm trying to think of other really funny answers. There were some hilarious answers to how you can dry some of these. Oh, who use a hairdryer? Something brilliant, guys. If somebody said, I've got something here, I need to dry it, and you start using a hairdryer, you're going to blow it all over the floor. Not a great choice. Brilliant, hilarious, but please don't dry with a hairdryer. Okay, moving on to the next one. Right, electrolysis making an appearance. And it's simply just 1 mark. You'll notice I've done a little bit of an unusual thing here with a multiple choice. I wanted to explain why each one of them went through this as you've got to do this by process of elimination. Multiple choices require a little bit more time than people think. I think students think they can just look at an answer and know which one it is. And most of the time, it's designed to trick you. Multiple choice is hard. The brown substance is bromide. No, that's genius in my eyes. Because everyone goes, yep, that was the biggest thing that everyone did. They just ticked the first one and went, jog on. No, it said bromide, not bromine. Genius trap. Second one, both products are elements. That is true. The silvery liquid forms at the positive electrode. No, because lead, which is the metal, is 2+. So it's going to go to the negative. The silvery liquid is molten. No, the silvery liquid is a metal. It's lead, not a salt. Right, this one was a disaster. This one was, they gave you a half equation and it was incorrect. By the way, I loved the question. What a genius way of doing it. Instead of getting you to write it, give you a bad answer and get you to spot the errors. Really lovely. And then, of course, it's got bromide, 2 bromides going in, which is correct, but then it's added the electrons. Well, if you've got 2 minus species, 2 minus items, and you put them near each other, they're going to repel. They're definitely not going to join together. So that's not correct. The electrons are on the wrong side. It should be spitting them out. And then the next one, so you can see my answers. Br shouldn't and wouldn't gain electrons. And the elemental bromine is diatomic. That there was quite clever, that, because I think a lot of people will put that as an answer for their writing it, not realizing, oh yes, bromine is one of my 7 that goes around in pairs. So clever question, really liked it. Explain why the lamp stops working after the teacher stops heating the lead bromide. This was 1 mark, and it was quite a long answer. Ionic compounds only conduct when molten or in solution due to the ions being able to move. And when you stop heating, the lead bromide will solidify. And once it's solid, the ions can't flow. So what the mark there was, when heating stops, lead bromide solidifies. Hence, you can't have, your ions can no longer flow through the structure. That was a tricky question again. Lots of students doing badly. Number 10, question 10 was better, hitting 80% pass rate. Everyone's picked up that reactions that where the temperature rises are exothermic. That was good. Right, guys, I'm gonna make a point here. All of you in year 11 seem to love saying the word amount. Do not do this. The word amount is officially banned in chemistry. Yes? Because if you say amount, if I said the amount of metal, well, that doesn't mean anything, because you need to say mass of metal, not amount, because you can have an amount of liquid. No, you can't. You can have a volume of liquid. Please don't use this term. If it's a solid, it's mass. If it's a liquid or gas, it's volume. So what things do we need to keep the same? We needed to keep the mass of the metal the same, and we needed to keep the concentration of the copper sulfate solution the same. There were other options as well. Add some metals and stir the mixture. Well, I think a lot of people were writing down, stir it the same. Well, that's not really such a great answer. There's going to be, I think students are often surprised that stirring doesn't make a huge amount of difference, and it's a bit of a misdirection that, and then they're looking to try and trap people to say it. Don't. Other options were surface area of the metal. That was okay. So to use the same mass, but if you were using granules versus turnings, you're going to change the surface area. So they allowed the surface area of the metal as well. So there were a lot of answers there, but those are your top two. Concentration of copper sulfate, I don't think anybody mentioned. People often ask me, how do you do that? How do you keep the mass of metal the same? You weigh it each time using a set of scales. How do you keep the concentration the same? You take the copper sulfate from a stock solution of known concentration. That's hard, that. People often don't know what a stock solution is. It's just it's a pre-made solution of known concentration. It's just called a stock. Your pre-made stuff that you keep in a cupboard. You'd often say that the shop has stocks of food, so their stock is the idea of a storage wherever. And if you're taking from the same stock, it's going to be the same concentration. Tricky. Right. Disaster. Titrations and reading thermometers and reading burettes as well. It's coming up in a second. But the temperature one, lots of people, this was actually answered pretty well. The majority of people got it correct. Just read your thermometer. I can't stress this enough. When you have these diagrams, do take your time with it. Don't rush it. I know you're in a rush to finish and it looks like an easy question, but that's 3 marks. And let's be fair, I could go back 2 pages and come across a 3-mark question, which was epically horrible. And this is a walk in the park. Every single person should be nailing this question. And so take your time. Don't rush it. Check your readings. Make sure that you're going, yeah, that's the right one. I think a lot of people who got that wrong were just writing down an answer and moving on, not thinking about it. This one was very bizarre. Lots of students getting this wrong, and it baffled me. Use the results above to identify the more reactive metal in the following pairs, Z and X. So what you had to do is look at the table and find zinc metal with X sulfate, and the temperature went up. This means that the zinc has displaced it. So the zinc must have been more reactive, so out the pair, zinc was higher. Copper and X, so you again find copper with X sulfate, no temperature change. That means that no reactions happened, so X must have been the more reactive. I think people were overthinking this question, to be fair. There are other ways of accessing that. If you looked at the other ones, if you did X and copper sulfate, this one here, the X, there was a temperature change, so the X is more reactive. It's going to be displacing the copper. I was going from the bottom there rather than the top, but you can do it in either direction. Write an equation for the reaction with the temperature rise of 2.7 degrees Celsius. Right, so you had to find 2.7 in the data, and I think a lot of people were freaked out by this question being X. They did not like it. And as I said, this is my rule again, my same rule that I've told students in the past. If students ask me, I don't know what I'm making. I get given what to put into the reaction, but I don't know what to spit out. If you're ever in that situation, now this is a last-ditch resort, but if you're ever in that situation, just swap the negative species, swap the non-metal. In this case, it's the sulfate ion. Just put it on the zinc and kick X off. Suggest why the students did not use calcium metal in the experiment. Now, I put it's too reactive. There were lots of answers to this question. You could have said that the reaction might have been too violent. The temperature might have gone up too quickly. You could have also said that you'd form a precipitate. Calcium forms a precipitate with a calcium sulfate, so the reaction's incomplete. But too reactive, I think, that was my initial response. And when I checked through the mark scheme, I was like, oh, interesting. I don't actually think that was the top answer. It was one of them, but it might not have been top. So bear that in mind. It's nice to simply use the reactivity series. I think those kind of questions come up on a regular basis, and I think it's a good go-to response to consider the reactivity series and recognize that calcium's high. Oh, it'll also react with water. It's another one, and not just the other one. So, okay, on to question 11. Question 11 got a scoring rate of 60%. And so, which piece of apparatus should the student use to add the sodium hydroxide solution? This required you to do a bit of reading, folks. You notice it said in the steps, add 25 centimeters to a conical flask. We're doing that with a graduated pipette. You know, that's the skinny thing with the middle bit being a wide body. It's the really, really clever pipette. It's just been to university, got itself a degree, it's super clever. Graduated pipette, not a burette. Burettes are used for variable volumes. That's what and this is the bit where it says add and it actually told you add the dilute sulfuric acid from a burette. So it should have been very apparent. Lots of people wrote in a burette there and just didn't consider. I don't think they read the full question. I think they just stopped halfway through. Right, knowing your indicators, folks. There's only two indicators that you need to actually, well, three indicators that you need to know for GCSE. Universal indicator, but you know your colours for that. You should do from year 7. But the two for GCSE are methyl orange and phenolphthalein. Phenolphthalein comes up far more regularly than methyl orange. So it's obviously one to make sure that you've got pink in alkali, colourless in acid. So, and then of course, colour after neutralisation, it's colourless. It's always pink in alkali. It's actually colourless in neutral solutions as well. So if you add it to just water, it's colourless. So pink and colours. Lots of people got it backwards. I understand why. You knew the colours, but you didn't know which way round it was meant to be. Just something for you to pick up. They do come up on a regular basis. So put it into your learn box. Right, next, reading your burette. This was a flat out disaster. Half the students were reading them upside down. Instead of reading them from top to bottom, you were reading them from bottom to top. It was a disaster. So the first one, of course, being, and of all, I thought this was genius. They also asked you for the after reading first. Lots of people got these two just backwards. So scored nothing, lost 2 marks. And it's clever that, because everyone sees the before and after first and just wrote down before and after here. So I understand the mistake. Again, take your time, try not to rush them. These reading questions, 3 marks. That means on this paper, there were 6 marks in total for just reading apparatus. That should take you less than a minute in reality, but people were rushing it because they think they're easy. Take your time. These are 3 marks. So make sure you're getting those right. Don't throw them away. So before 23.5, remember, you're from 1.5, you're reading top down. So 23.15. The next one, the before, you're reading from 1, I'm going down to 1.4. Notice I have underlined this 0. Very few students, less than 5 in the year group, got this mark. The reason being is you just put 1.4. And burettes must be read to 2 decimal places. So it's either 5 or a 0 at the end. Really, really easy mistake. And it's because you can get the 0.5 from that one. Next, volume of acid, 21.75. Most students got that one. It was pretty solid because, of course, even if you got them backwards, you still got the right number. Next. Oh, titration continues. Tick the box. Lots of people tick them all. Don't. So you can only take an average of the 2 within 0.1 of each other. So that's the last 2, 21.1 and 21.2. So those 2 required to be ticked. Lots of people just added all 4 together. There were errors carried forward here, but and I'm sure we did. So add them together. By the way, people didn't. It says you've got to show you're working. And lots of people didn't. Use your ticked results to calculate. It's 2 marks. Year 11, you cannot get 2 marks by simply writing in an answer. You've got to show you're working out. So please do so. You can see I've dropped into concentration, C times V over 1,000 again. I'm pulling my data from the question. Should have been pretty straightforward. Mole ratio appearing. It then said calculate the moles of sulfuric acid. It was in a 1 to 2. You can see, and look, it was over here on that side. They gave you that. So you had to then do your little step across. You had the moles of NaOH. So it's a 2 to 1. Divide by 2. So to be honest, it's only 1 mark. So technically I didn't need to show the divide bit. I should have done 0.06 divided by 2 gives me 0.03. Notice I've done it to 3 significant figures as well. It actually didn't mind if you didn't do that, but I always like to do so. Calculate the mass in grams. Once you've got moles, to 1 mark for working out. And look, show you working. H2SO4, MR 98. Reorg, look, you can see my then rearrangement. Number of moles is grams over rams. You bring the rams over, bring it over to here, multiply both sides. You get number of moles times rams gives you grams. And you can see how I've taken my MR from this bit, my moles from question 0.2, and then I get my 2.94 grams. So something to consider. These questions are going to be on your papers. I can tell you what's going to be on your GCSE paper year 11. Titrations are going to be there. Make sure you've got it down and you're well practiced. I think we're on to the last question, folks. Question number 12. Again, 60% outcomes, same as question number 11. So suggest 2 features of the marble chip the students would keep the same. Mass of the marble chip. Do not put amount. Same thing again. Notice the same thing appearing twice there in the same paper. Surface area of the marble chip. Easy one to pick up. Mass and surface area. Why does the mass of the flask? I think everyone got this right. The mass of the flask decreased because carbon dioxide gas is escaping. Now, question C, everybody got wrong. Because, right, guys, if you stick cotton wool in the end of something, is it going to stop a gas escaping? It's not a cork. Yeah, if you put cotton wool in, the gas is going to still escape. I don't know. Everyone seemed to think that if you shove cotton wool in something, all the gas is going to be kept into it. I don't know if you guys have ever seen cotton wool, but it definitely won't do that. The cotton wool will prevent water droplets from escaping. Because when something produces a gas, it spits. And I don't think a lot of people got that. I think that probably is a lack of actually seeing it happen when you've done it practically. I was doing a practical today where I added calcium to water, and lots of people were saying, I can see steam, I can see steam. And that's the water being thrown up by the gas. It's not actually steam, it's just water droplets being thrown into the air. So the cotton wool prevents the water escaping. Next, question number, I think this is the last one, I think. Next one says, use the graph. Right, people didn't bother to draw on the graph. So, and also, you guys have an allergy to rulers. You hate using them. Okay, I have to admit, this is quite funny. I haven't used a ruler. Sorry. And yes, I'm having a go at you, and I'm having a go at myself. You need a ruler because, like, I say I haven't used a ruler, but I haven't, but I can follow straight lines. Yeah? You guys can't. You guys were drawing these, see my dotted line running along this line. You guys were just wandering up, crossing over lines, and then thinking that it was level, and it wasn't. So common mistakes were saying 220. That was a very, very common mistake, giving 220 seconds instead of 210. You've just gone up 1 square because it's not level. And yeah, it's using a ruler, and even I didn't do it, sorry. On the point on the graph, it says you could have caused, what could have caused the anomaly? This was hard because you had to almost imagine doing the practical yourself. So it says one of the points on the graph is anomalous, which could have caused it. The concentration of the acid was more than 40%. Right, the 40% one is way too high. What would have happened if the concentration had been higher? Well, look at the graph. It wouldn't have gone higher. It would have gone lower. That's hard, that. You had to use the graph to help you recognize what that A was doing. The next thing, the loss of mass was greater than 1 gram. Right, hang on a minute. If the loss of mass was greater, so okay, if the loss of mass was greater than 1 gram, so if you'd put in calcium carbonate, the limestone, and the limestone had got more calcium carbonate in it and had other impurities, then it would mean that more gas was given off. They didn't keep the limestone the same. So they've probably put in either too much marble chips and got too much gas, or the marble chips had got impurities. So that's true. The mass of marble chip was more than 10 grams. Whoa. Well, hang on a sec. They only put in 1 gram. If you put in 10 grams, you'd get 10 times more than you'd expect. Well, you wouldn't have had the tick up there. It would have been through the ceiling. The students started the timer too late. If you started the timer too late, then the time would have been lower and not too high. That was a really tricky question, that one, and I thought that was really hard, hence the writing of hard on the question. Okay, next one. Calculate the rate of reaction when the concentration of acid was 50%. So what you had to do is you had to go 1 over 220. You took your reading off it. Rate, you can see my equation. Rate equals change in product over change in time. So I could have put in change in product was 1 gram, and the time was 210 seconds. So you'd run that through your calculator and you get your answer. 3 significant figures. Lots of people putting in 0.05 and losing it. So just bear that in mind. Right, the graph question. Once again, rulers. You guys are even doing, like, you're doing lines of best fit without using rulers. But actually, the most common mistake was students didn't bother to go through the origin. You were just stopping at 20, joining the dots up, seeing the line of best fit, and then just stopping there. I circled the end of it. You've got to realize that that is going through the origin, so your line of best fit must. That was the only real mistake on that one. The last question, the rate of reaction increased as the concentration of acid increased. Explain this in terms of particles. You can see I've used my little method here for kinetics. Knowledge, collision frequency, activation energy, and successful. So the knowledge was as you increase concentration, that will mean there will be more particles per unit volume. The collision frequency, well, if there are more particles per volume, they're going to collide more frequently. And lots of people were just saying, they're going to bump into each other more. It's kind of what they were doing. And it's just, you need to be putting this in more coherent chemistry sentences, and this is a nice way of doing it. You don't even need to have real sentences. Those 3 words are enough. Collision frequency increases, and therefore there are going to be more successful collisions. Lots of students don't realize that there is a difference between collision frequency and more successful collisions. You can't just put there are more particles, so more successful collisions. You can't do that. You have to mention collision frequency, hence it being in my acronym of knowledge, collision frequency, activation energy, and successful. You'll notice I've crossed out the activation energy. That's because that one only gets mentioned when you have a change in temperature, and of course in this case we're not. That brings us to the end of my webinar, folks. I hope it was useful. I hope it's also worked. I'll see if I can, oh, I've just closed it. Stop broadcasting. Let's see if I can find that. I'll also see if I can not share my thing. Screen share. Can I get rid of that and bring me back? 11 viewers. I hope this has worked, guys, and you've been able to hear me okay. As I'm hoping it's also going to have been recorded, so you guys will be able to watch it back if you want to go through it at a later date. And of course, anyone who wasn't here, it looks like I've only got 11 viewers. So we will see tomorrow what you guys think. And I'd love to get your feedback. I'll create a Google form that you guys can fill in. I hope you've all had a nice evening, and I'm sorry that if I've taken your time. It's taken us, considering I started late at about 7:40, about 6:45, it's taken us an hour to do, which is really good because it just saves us all that time in lesson. Anyway, guys, have a lovely evening, and I'll see you all tomorrow. Bye, guys.